Hello, and welcome to my SUSECon talk about Kubernetes Multi-Cluster Management with SUSE Rancher. My name is Bastian Hofmann. I'm a field engineer at SUSE, and my main focus is on our container and Kubernetes-related products. So Rancher, Harvester, New Vector, Epinio, and so on. Today, I want to talk to you about why you actually want to use Kubernetes to manage your applications and why everyone is talking about this. How SUSE Rancher can fit into a Kubernetes management strategy and how it can help you manage multiple Kubernetes clusters. And then we are going to dive directly in and have a look at how you actually can deploy SUSE Rancher very quickly on some virtual machines, and then how can you use it to provision clusters and manage your workloads. But first, let's start with containers. Containers are great because they allow you to package your applications in a very portable way and make it a lot easier for you to deploy, run, manage, and monitor your applications wherever they are going to run in the end. The way containers are doing this is that you can use container images and then package your whole application, including all application dependencies. So something like a programming language runtime, a web server, additional monitoring daemons, binary tools that you need. All of that can be packaged into one standardized container image. And then you can take this image and start it on any kind of server that has a container runtime, so something like Docker, for example, or CRI-O or Containerd or Podman, and run this container image in a self-contained isolated container. You can think of a container image as something like an archive file. And this archive contains the whole file system that your application needs, all the files, all the binaries, all the tools, all the configuration, potentially. And then when a container runtime takes such an image and says, now I want to start this container image instead of a container, it extracts the file system and starts up a process in it. And through Linux kernel features, this process is then isolated from all other containers. So an application running inside of a container only sees itself, and it only sees its container file system. It doesn't see anything else running on the server, on the host. And this is great because it allows you to package your application in a standardized container image. And then if you want to run it on a server somewhere, you just take the image. You only need a container runtime on running on the server. You can start it up. Your application is up and running. And when you're finished, you don't want an application there again on the server or virtual machine. You can just stop the container and you have a clean system again. And if you have 1, 2, 3 servers and a couple of applications inside of containers, it's very easy. You bolt your container images, transport the images to some server, and start and stop them as you need. But usually, a system and a production system environment does not look only like this. You have usually more than 1 or 2 applications running somewhere in your organization. And oftentimes it more looks like this. You have dozens, hundreds of servers and virtual machines running somewhere, dozens and hundreds of different applications, some user-facing, some internal, doing all kinds of things. And then it can become quite challenging to decide, okay, which container should run on which server? How do you set up then the networking between the containers so that only the containers who are supposed to be talking with each other can talk with each other? How do you ensure security, and how do you ensure that the resources that you have, CPU, memory, disk space, are used in the most efficient way, and not some servers are completely idling and sleeping and doing nothing while others are completely overtaken with load. And when you have these challenges, what you can of course do is you can create your own automations. You can create your own scripts to decide which containers should go where and to orchestrate the starting and stopping of containers in your environment. And of course, the configuration of networking, etc. You can write this on your own, But since containers are standardized and independently from what's inside of a container, from the outside, they all look the same. It is a good idea to maybe then also use a standardized tool for automating all these networking and scheduling decisions. And that is where Kubernetes comes in. Kubernetes is a container orchestration platform that you can install on your servers. All these servers can form a Kubernetes cluster. And then you can tell Kubernetes, please start and stop or run these containers, and Kubernetes will do it for you and make a lot of decisions on the way for you to help you manage and run the containers. And the reason why everyone is talking about Kubernetes is that it's nowadays can be run on a lot of different infrastructures. You can run Kubernetes on a developer laptop to ease development and standardize that. You can run Kubernetes in your data center on premise, on virtual machines or bare metal servers. Of course, you can run also Kubernetes in the cloud on the big or smaller public or private cloud providers. But Kubernetes can also be used in more non-traditional environments like IoT and edge environments where you have small industry PCs in factories or in a supermarket shop. You also have a couple servers there that manage the shop maybe on 5G cell towers, in trains, in cars. Wherever you need to run software and manage software, Kubernetes is very flexible and can be used there to give you a standardized API to start and stop your containerized workloads. And Kubernetes not only cares about starting and stopping containers, it also has standardized APIs to set up the networking in between, to configure network security policies and firewall rules, to handle auto-scaling, backup and disaster recovery, role-based access controls, health checks, load balancing, and so on. So it's a very powerful tool. If we look in a bit more detail in how Kubernetes does this and how the Kubernetes architecture of a cluster looks like, you oftentimes see like these kind of like diagrams, and they give you a bird's eye view of a simplified architecture of a Kubernetes cluster. On the left, you have the user, and the user uses the Kubernetes API either directly or through a tool like a Kubernetes CLI client to tell the Kubernetes cluster in what state it should be. So what containers should be running, how they should be configured, how the networking should work. In the middle, you have the Kubernetes control plane, which consists of the Kubernetes API and a couple other microservices and controllers that continuously run and query the API to make decisions on scheduling and decisions on automation. And the Kubernetes API receives the API calls from the user and stores the desired state in a etcd key value store. And then on the right side, you have your worker nodes, and these nodes constantly also query the Kubernetes API and ask Kubernetes, hey, what containers should I start? What containers should I stop? How should I configure the network, and so on. And then they also report back their current state so that the Kubernetes API also knows about not only the desired state that the user wanted, but also about the actual state that the nodes report back. And this is also then stored by the Kubernetes API in etcd and taken in consideration when making scheduling decisions. And I already said, like, Kubernetes is an architecture or a tool that you run on multiple servers. It forms a cluster, so you have a distributed system there here. And you have multiple components, multiple microservices that together make Kubernetes. And this diagram here is simplified. So there are multiple components running on each node for different purposes, and there are also multiple components running on the control planes for multiple purposes. And that means when you set up a Kubernetes cluster, you have to care about consistent configuration, you have to care about certificates and secure communication between all of the components. And of course, you also have to care not only when setting this up, but also when upgrading your cluster to a new Kubernetes version. And of course, you can do all of that by hand, but setting up Kubernetes by hand is kind of hard. And here in the screenshot, you can see a tutorial done by Kelsey Hightower called Kubernetes the Hard Way, which goes step by step from like completely empty Linux VMs, how you can set up Kubernetes by hand. And it's very interesting. You'll learn a lot. And one thing you probably also are going to learn that you don't want to do this in production yourself. And I always like to compare this also to Linux. With Linux, it's very similar. You can compile a Linux kernel and all the packages from scratch, but it's a lot of work and probably not something you want to focus on because you want to focus on developing and running your software and not on compiling Linux. So instead of doing everything yourself, you use a distribution like SUSE Linux, for example, that can help you with that. And the same thing is also happening now, or started to happen a couple of years ago, with Kubernetes. So instead of everyone running and configuring their Kubernetes on their own, you can also now use a distribution that helps you with setting up Kubernetes in a highly available way and also provide then upgrade capabilities without having a downtime of your applications running inside of the cluster. And with SUSE, we are offering 2 Kubernetes distributions for different use cases. The first one is the Rancher Kubernetes engine called RKE. This is the general purpose Kubernetes distribution that we offer. You get 100% upstream Kubernetes without any modifications. So it behaves exactly like a Kubernetes cluster is supposed to behave. The whole distribution is also certified by the Cloud Native Computing Foundation, the CNCF, to be 100% standard compliant. And then it offers you a very easy installation, also very fast installation. It offers you 0 downtime upgrades for both the workloads running inside of the cluster and the Kubernetes control plane and the Kubernetes API itself. It handles backup and disaster recovery. It is, of course, installable completely in air-gapped scenarios where you don't have any internet connectivity due to security concerns. And it's configured and hardened for security out of the box so that you have a secure configuration with all the defaults. You still have the flexibility to change things if you want to, but the default configuration is already secure and hardened for security. So much that it even then also complies to federal standards for security like the FIPS standard. The second Kubernetes distribution that we offer is K3s. K3s also gives you a completely upstream Kubernetes that is certified by the CNCF to be standard compliant. But some of the choices that has been made with what tools and what plugins are bundled with it, what add-ons are in there, and how the default configuration is, makes it a lot more lightweight in terms of CPU memory consumption, which makes it a very good Kubernetes distribution to run on a developer laptop or on IoT and edge devices where resource consumption is a big concern. It is still very easy to install, has 0 downtime upgrade capabilities, has a way to do backup and disaster recovery, so all the things that you need, but it has a very small CPU memory footprint. Of course, that also comes to a cost, like a lot of the default security configurations that RKE has and a lot of the more large cluster enterprise features that you may need, for example, in terms of network policy and firewall controls, are not on and configured by default in K3s. And yeah, these distributions are great, and you can pick them and use them and install them on a couple servers. And if you have 1 or 2 Kubernetes clusters, that's great. That's really easy to manage. But if Kubernetes becomes now more and more used in your organizations and more departments are using Kubernetes, quickly you will end up not only with 1 or 2 clusters, but also with multiple Kubernetes clusters. Because maybe you are not only having a production system, but also a testing and staging or QA system or development systems, and you want to have them separated from your production Kubernetes clusters. Maybe you also have multiple development teams and you may end up with 1 Kubernetes cluster per development team for dev so that different teams are not negatively affecting each other during development and to segregate the workloads a bit more. Maybe there are certain workloads in production that, because of regulations, need to run on its dedicated hardware, or they are managed by third-party vendors and providers, and also need to run in their own clusters. Or you have multiple data centers, or maybe you're even running in a hybrid scenario and environment where some workloads are scheduled and run in the cloud, other that are more sensitive are running on premise. And if we're talking about these IoT and edge scenarios, we are also running Kubernetes on industry PCs or maybe in cars or trains. You quickly end up not only with a few dozen clusters, but maybe even with hundreds or thousands or millions of Kubernetes clusters. And then it can become quite challenging to manage these Kubernetes clusters, to set them up, and to configure them in a consistently and secure way regarding role-based access control, monitoring, security policies, and so on. Additionally, you also not only need to manage the Kubernetes cluster itself, but also the workloads running inside of the cluster. The way Kubernetes does this is with a declarative configuration approach. Everything in Kubernetes, a running container, a persistent volume, a key value configuration map, a routing rule, a firewall, network policy, everything is a RESTful resource in the Kubernetes API. And you can interact with Kubernetes by creating, retrieving, updating, and deleting the resources. Let me give you one example. Here you can see the API specification of a deployment. A deployment tells Kubernetes to run a container multiple times in the cluster. So in here we have a deployment which has 3 replicas configured, and in the specification of these replicas it says please run an Nginx container. If you send this deployment configuration to the Kubernetes API as a user, Kubernetes will then see this, store this in etcd, and it will start running 3 containers where there is space on the nodes with Nginx. And it also has some self-healing capabilities, so if one of the containers one of the replicas dies, then Kubernetes will also see, hey, there are only 2 of the 3 replicas available, so it sees there is a mismatch between the declarative configuration that you sent in and the actual cluster state, and it will restart the container that crashed or broke somewhere else where there's space and where it can run. And this is a very powerful concept, but of course you have to then learn the API and the API objects, and that it's not just deployments you have to learn about, but all the other features that Kubernetes offers as well, which means the Kubernetes API has a learning curve. And to help you with that, managing the workloads and making it easier to manage the workloads without maybe having to become a complete Kubernetes expert, but also managing the Kubernetes cluster itself, there Rancher comes into play. Rancher is a central multi-cluster Kubernetes management platform, and you can use it to manage everything from 1 to thousands of containers, Kubernetes clusters, regardless where they are running. So within a single Rancher instance, you can manage Kubernetes clusters running in the cloud, running in your data center, and or running on an IoT and edge devices. Rancher also supports every standardized Kubernetes distribution and has first-class support, of course, for KSRS and RKE, the Kubernetes distributions from SUSE Rancher, but also for the major cloud provider Kubernetes distributions like EKS, AKS, and GKE. And on top of the Kubernetes cluster management, provisioning new Kubernetes clusters, upgrading them, it also offers lots of tools for managing the Kubernetes clusters itself and the workloads running into them. You can set up authentication and authorization centrally for all of your clusters to decide which users or which groups, for example, from your Active Directory, are supposed to have which permissions inside of the cluster. You can set up centrally security policies, networking rules, firewall rules, monitoring, log management, service meshes, or even with NuVector also set up container security. And on top of that, you can also use SUSE Rancher to manage the application workloads running inside of these clusters. So it's a very powerful tool. And For the remainder of the talk, I want to show you how you can set up Rancher and give you a first taste of how you then can use Rancher to manage your Kubernetes clusters and workloads. For this demo, what I prepared is I prepared a couple of virtual machines here on the left. Rancher in the end is also a workload running inside of a Kubernetes cluster. So Rancher is not as a tool is not reinventing the wheel. It's also making use of the multi-cluster of the high availability capabilities that Kubernetes has out of the box. So at first we need a first initial Kubernetes cluster. For that we are using K3s because it's just very fast to set up. And then we install Rancher as a workload as containers inside of this K3s Kubernetes cluster. In front of this Kubernetes cluster, running on 3 virtual machines, we have a load balancer that load balance incoming traffic from port 80 and 443 to port 80 and 443 on all of these VMs. And then I set or created a DNS entry that points to this load balancer. Once Rancher is installed, it can be used to manage the Kubernetes cluster Rancher itself is running in, and then we can use it to add additional workload Kubernetes clusters on any kind of infrastructure. And these then connect back to Rancher, so that and through that they also make Rancher manageable or the Kubernetes clusters manageable by Rancher, that way around. So let's have a look. And let's first of all switch to the terminal. So here on the left side, you can see the IP addresses of the VMs I prepared. In this case, they are running on AWS, but they can basically run on any kind of infrastructure provider. This is the address of the load balancer that load balances incoming traffic on port 80 and 443 to port 80 and 443 of these 3 nodes. And then this is the DNS entry here that I created that points to this load balancer. Here on the right side, let's make this a bit bigger. I have SSH connections to all 3 virtual machines. And these virtual machines are running SUSE Linux Enterprise 15 SP2, but also Rancher and the RKE and K3s Kubernetes distributions supports a huge variety of Kubernetes distributions, of Linux distributions. And there are no other modifications made here. There's nothing else running on the machines. So first, we want to install on these 3 virtual machines a K3s Kubernetes cluster, and then use this Kubernetes cluster to install Rancher. Installing K3s is very easy. We provide a small installation script that you, if you want to, can just download and run. And this will just find out what is the latest stable K3s version. It will download it. It will verify that the download hasn't been corrupted. And then it will put the binary that it downloads to user local bin. If necessary, it also will create some SLinux or install SLinux policies. It will create a couple symlinks for convenience, a script to uninstall everything again, and a systemd service. And the systemd service is then also already started. Note that in the arguments for the script, I'm telling I want to have a server node, I want to initialize a new cluster, and I'm provided an authentication token. This is important later on if I want to join 2 more nodes to this cluster, because this token is then used for authenticating so that not everyone in the internet can join the cluster, but I need this token in order to authenticate and add a new node to the cluster. And the first node is up. I have a Kubernetes cluster. So let's have a look at the cluster itself. And in order to use the cluster, I need to provide a configuration file called a kubeconfig to my shell. And this kubeconfig is automatically created in etc rancher K3s YAML. And basically this configuration file tells command line or tools that interact with the Kubernetes API, like a command line tool like kubectl or other tools, IDEs, CI/CD systems, where the Kubernetes API is and how to authenticate against it. And now I can use the Kubernetes command line tool here called kubectl to say maybe kubectl get nodes, and get myself a list of all the nodes in my cluster. And maybe I can also watch this, and then so that it repeatedly updates the command. And then on the other two nodes, I can run the same installation script with the same auth token, but I'm then additionally telling the K-Series installation script, please don't create a new cluster, but join the existing cluster here on the IP address of the first node. And I'm going to do this 2 times, and you can see the second node already joined the cluster and is ready to run containers, and the third node should also be up and running momentarily. So that took, like, with a bit of talking, 2 minutes. If I hadn't talked, this would be more like 40 seconds, and I have an up and running, highly available Kubernetes cluster. This is awesome. So let's maybe make this here up here a bit bigger, because we are only going to use the first node now to interact with our Kubernetes cluster. Now that we have our Kubernetes cluster up and running, we can start installing Rancher inside of the cluster. And of course, I could now create all these deployment manifests for Rancher myself, or I maybe could download them somewhere. But as you can imagine, Rancher is a more complicated tool. It's not just one container that you're running somewhere. You need additional routing configurations, some secrets configurations that you put in. And yeah, to make it easier to install a more complex tool like Rancher inside of a Kubernetes cluster, we can use a package manager for Kubernetes called Helm. And with Helm, we can install completely predefined packages of multiple Kubernetes resources inside of any Kubernetes cluster, and then just configure the things we want to have differently to our liking. And in order to use Helm, I also need to install a Helm command line tool. This is here also done with just downloading and executing a script, which downloads the Helm CLI binary and puts it to user local bin. And now I can use Helm to interact with my Kubernetes cluster and, for example, list all the things that are already installed with Helm. And you can see there's already stuff inside of my Kubernetes cluster installed. In this case, it's a traffic ingress controller, which takes incoming traffic from the outside and distributes it according to routing rules on layer 7 inside of the cluster. The reason why it's already installed is that it's part of K3s, and K3s also internally uses Helm to manage all the add-ons that it brings and comes with. Next, we can now use Helm to install stuff. When we want to run Rancher, Rancher offers us a web UI and a web API to interact easily with my Kubernetes environment. And we're talking web UI. We probably also will need a TLS certificate to have the web UI and API exposed securely. And of course, we could provide our own TLS certificate, but Rancher can also interact directly, if we want to, with Let's Encrypt. And to make it easy, I'm just going to do that. In order to get certificates from Let's Encrypt, Rancher integrates with a standard tool in the Kubernetes environment to do Let's Encrypt integrations called Cert Manager. So the first thing, actually, before installing Rancher, if we want to use Let's Encrypt and not provide our own TLS certificates manually, we need to install Cert Manager. And we can also do this with Helm. So the first thing, in order to install anything with Helm, is that we have to add the repository where a Helm package, a Helm chart comes from, to our local repository index. And we can do this with Helm repo add. That does nothing yet with the Kubernetes cluster. I could run it on any machine where I actually have a kubeconfig to connect to the cluster. It just downloads the repository index and puts it into a local cache. And now we can use this repository index to install a Helm chart from it. And in this case, we are going to install Cert Manager. And we can say, Helm, please install us or upgrade us if it already is installed From the Jetstack repository, this is one I added here, the Cert Manager package. Call the release name of the Cert Manager, install it in a Cert Manager namespace. Namespaces are kind of like a folder structure inside of Kubernetes. I want to install the version 171. I want to create the namespace Cert Manager if it's not created yet. And I also want to install custom resource definitions. These are things that extend the Kubernetes API with additional API resources. And Cert Manager uses this to automate the creation of certificates. And now the package is installed. And if we have a look at all the pods in our cluster, for example, inside of the Cert Manager namespace, you can see I have Cert Manager up and running. And now we can use Cert Manager and Helm to install Rancher and automatically get TLS certificates. So let's do that. And of course, I forgot something. If we want to install Rancher from the Rancher latest repository, I also have to add the repository to our local repository index. So let's do this again. And same command, or very similar to Cert Manager, we are saying, hey, from the Rancher latest repository that we added here, install the Rancher Helm chart in the Kettle system namespace with the version 264. Create the namespace if it doesn't exist. And then we are configuring the Helm chart to set the host name to the DNS entry that we created here beforehand and pointed to a load balancer that points to all these 3 virtual machines where the Kubernetes cluster is running on. And we are saying, hey, please use a Let's Encrypt TLS certificate. There are a few more options that you can set here and how to configure Rancher. More of that you can find in the Rancher documentation. And now we should have Rancher up and running. Let's have a look at the pods inside of the Kettle system namespace. You can see there are 3 pods. They are not ready yet, but they are already running. They are not ready yet. It means that the health checks are not reporting back that the pods are healthy, but also that should happen momentarily. While we're waiting for the Rancher pods to come up, what we can also check an ingress that Rancher created, and this is an internal routing rule that says incoming traffic with this host name should be then distributed to the Rancher pods. So that's the way how we can, with an ingress, we can expose our Rancher application to the outside world. It's a very standard way how to expose applications in a Kubernetes cluster. So let's check again the pods, and they are up and running now. So if I take this URL and go back to a browser, I can access the Rancher web UI and I get the initial configuration wizard. For security, the first thing is I have to retrieve a bootstrap password that I can put in here so that not everyone can go through the initial installation wizard. So let's retrieve the bootstrap password, copy it over, and paste it in here to log in. And then we can provide our own password for the initial admin user. We can agree or disagree to a collection of anonymous statistics. We can agree to the terms and services and then continue. And we are all set. And we now have the Rancher dashboard. And we already can see a local cluster available here. And this is the Kubernetes cluster where Rancher itself is running in. So we can also start managing that. The first thing you're probably going to do in Rancher, you can set up your global users and authentication system, connect your LDAP or Active Directory, and then you're probably going to start creating new clusters or maybe importing existing clusters. Let's do both. Let's first import an existing cluster. I can import clusters from the big cloud providers or just like any Kubernetes cluster. Let's give this one a name. And now I'm getting a generated Kubernetes manifest that I can just execute and deploy into any Kubernetes cluster to make this manageable by Rancher. So if we go back here to my terminal and to the second tab, I already prepared here a Kubernetes cluster. This Kubernetes cluster has a couple more nodes, should be 5 of them. And if I just now deploy this generated manifest from Rancher inside of the cluster, in a couple seconds later, I will have this cluster then manageable by Rancher. If I don't have a Kubernetes cluster yet, I can also create new ones. And I can create ones directly by connecting Rancher to one of the big cloud providers or infrastructure providers to directly deploy a Kubernetes Amazon AKS, or GKE cluster, or to connect to an infrastructure provider that provides virtual machines. And then Rancher will connect to AWS or a VMware vSphere or Harvester, DigitalOcean, and there's actually a plug-in system behind it, so I can activate more, also deactivate some of the cloud providers, infrastructure providers here. And then Rancher will create virtual machines and then roll out its RKE distributions all in one go. And if I don't have an infrastructure provider with an API, or I don't want to connect Rancher directly to the API of my vSphere or my cloud provider, I can also create a custom cluster here. And what this will do, it will first of all also ask me, okay, how do you want to configure the Kubernetes cluster? Which version of Kubernetes do you want to run? What do you want to have Windows support or not? Which networking plugin do you want to run? Do you want to use private registries for air-gapped setups? Lots of other options you can take. And then when you don't forget to enter a name for the cluster, you get a small installation command that you can then just run on any server, on any virtual machine, to make it a worker node inside of the cluster, a control plane node, and or an etcd node inside of the cluster. And also you can get back to this command and print it for you any point in time. So this way you can also hook up systems, virtual machines, bare metal servers to Rancher and install Kubernetes on them without having to connect Rancher to an infrastructure provider. If you connect it to an infrastructure provider, though, it will be then also the complete VM management will be done by Rancher. So multiple ways of working with Rancher and using Rancher and provisioning Kubernetes clusters are possible, and we don't lock you in into a certain way of working here. So my lab cluster is now completely registered in Rancher, which means it is here in the cluster management tool available, but I can also see this in this explore section in the global menu. And if I click on it, I then get a view inside of the cluster. And now I can interact with the Kubernetes cluster with a very nice UI that makes it very easy to interact with Kubernetes. On the top menu, I have the possibility to import any kind of Kubernetes YAML manifest directly here. If I just copy and paste it, I can open up an interactive kubectl shell to maybe interact with my Kubernetes cluster and kubectl, the command line tool, directly from the browser. So here I could say kubectl get nodes, and I have a shell inside of browser to interact with Kubernetes if I want to. And I also can generate myself or download myself a kubeconfig. And this kubeconfig I can then put on any machine that has access to Rancher or can connect to Rancher. And then I can use tools like kubectl or CI/CD systems, IDEs to then also interact with this Kubernetes cluster. So Rancher is not hiding the Kubernetes API at all. You can still use it. In addition, you have a very intuitive UI to interact with Kubernetes as well. And these kubeconfigs here are, of course, tied to the user that I'm logged in with at Rancher. And I only will have the permission inside of the UI, as well as with kubectl or other tools that were assigned to me to this cluster by the administrator. On the left side, I can access all the Kubernetes API resources. I see all my nodes inside of the cluster. I have access to all my workloads. I can see all the deployments. I can click on a deployment. I can see more details in there. For example, I can see this deployment consists of 3 replicas. And if I want to, I can also from the UI quickly view the logs that are running through the container live. And I guess I picked one that just doesn't log anything. I can also execute an interactive shell inside of the container if I want to do quick debugging or directly from the UI. And I can do this not only with deployments and pods, but also with cron jobs, with persistent volumes for storage, with config maps, with for ingress rules for service discovery, network policies, and firewalls. Everything that Kubernetes has to offer. Now, of course, cannot only see the stuff that is running inside of the cluster, I can also create new things. For example, in here I can say I want to create a new deployment with an Nginx from the Nginx container image. I maybe also want to create a small port and expose the port 80 of my application. And if I click create, you can see my Nginx is now starting up and running. And you can also see the status here again, and it just start up. Let's have a look at the logs here, and you can see the logs of my Nginx. And of course, I can also reach the Nginx because I exposed this. So if I click here on the endpoint link, you can see the Nginx running up and starting in the browser. So that easy, you can interact with Kubernetes and intuitively create and deploy applications to your Kubernetes cluster. And if you don't want to create everything, all the resources manually, you also have access to an application marketplace that you can use to install additional features and functionalities to Rancher, for example, to configure the monitoring or service mesh, or to install applications from partners that like Artifactory container registry to the cluster, or monitoring daemons of different providers. And of course, you can also create your own and add your own repositories to make other third-party applications or even your own applications installable, also with a couple clicks through the application marketplace. Rancher has tons of more features. For example, an integrated monitoring, where that gives you then also alerts or nice graphs about the usage of CPU, memory, disk, and network of your nodes, as well as your containers. You have log shipping included, Longhorn as persistent storage, new vector for container security, Istio as a service mesh, and more and more. So there are going to be a lot more talks about specific features like this during SUSECon. And of course, there are also a couple more resources available to get more information and how you can continue using and exploring Rancher once you have it installed. So let's go back quickly to the slides. And the resources are, first of all, of course, the documentation of Rancher itself. Then the documentation of K3s or RK2 for specific Kubernetes distribution specific things. And from there you have documentation about all what you have seen today and all the additional features that Rancher offers. And with that, thanks a lot for your attention. Have fun playing around and testing out Rancher, and hopefully see you soon. Bye-bye.